Hello everyone. Today we're gonna go through this what's it called? Basically this question, like I did it in lesson, and it's what we really need to know how to solve. Well, I really need to know how to solve for my engineering exam. That's literally in 3 days. I'm very scared, but let's just go cracking. So first of all, oi, yeah, never mind. First of all, let's write down what we actually have. So we have the voltage. So what you have to remember is that if the voltage like this, when the voltage is like this, it's the actual voltage. However, if the voltage was like V peak equals something, or VP equals something, then the voltage, like this number, you divide that number by square root over 2, and that's the actual voltage that you have to use. So yeah, remember that. After that, we have the frequency, 50 hertz. After that, we have the resistance, 20 ohms. And then we have the, what's it called? It's coil, I'm pretty sure it's, yeah, inductance, I think. I think it's inductance, I can't really remember. So it is 100 millihenry. Yeah, I'm pretty sure it's Henry. So, and we need to find the, like, resistance of it. Like, we don't need this one, we need it in ohms, if that makes sense. So basically how we do this is the formula. So the formula says that XL, so like the X, I don't know what the X is, but basically, yeah, this is what we need. Equals the 2 pi times frequency times the L. So we have the frequency, we have the L, and we have the 2 pi. So we just times all the stuff together. So basically, this 2 times pi times 50 times 100 times 10 to the power of minus 3, because that's what milli is. And this all thing equals to 31.42 ohms. After that, that's all that we need. And then we have to look for this one, that is the capacitance. Capacitance is measured differently, slightly. Basically, the XC equals 1 over 2 pi FC. So basically the same thing, but with this thingy-majiggy. The formula is given in the formula note, so don't be scared that much. Even though I am scared. So basically that XC equals 1 over 2 pi times 50 times 150 times 10 to the power of minus 6, and this all equals to 1 point, oh no, I'm wrong. What am I? No, I'm not. Sorry. Equals to 6 equals 21.22 ohms. So whatever you get here, it's over 1. So yeah. After that, since we got these two, we look in the we have to use Ohm's law next. So we have basically the resistance of all of these, and basically Ohm's law says that I equals VR. However, because like we can add them all together, but like at the same time we can't. Basically, instead of R, we're gonna use the, and I don't know what like the name. Basically, it's the Z. I can't remember what it is. Maybe it's on. Maybe it's inductance. I'm really not sure. But basically, how you work out Z, because we don't have Z anywhere here. Z equals the square root of R squared plus the RC, take away RL, take away X Z squared. And also, however, if you didn't have like the capacitors, for example, it would only be. Wait, let me actually check the formula sheet because I kind of don't even know. Yeah. Basically, it would be without like one of them. It would be the just plus thing with one if it was one. Basically, yeah. So this is 20 squared. This is this. This is this. How do I do this? Because I don't want to write them down. You know, it's like just yeah. So basically, z equals 2.45, and that is in ohms. So it's the same as resistance because also in ohms. So we have the voltage, which is 20 divided this divided by this, and then we get the current, which is 0.89 amps. After that, so we basically did the first question. This would be worth like 10 marks. I mean, that's what my teacher said. And now we have to calculate the voltage drop across each of the components. So each of these, we have to work out what is the voltage drop. And that's easy, as voltage equals I times resistance. So for the first one, it's going to be 20, like we know the current is 0.89. 20 times the 0.89 equals 17.8 volts. For this one, we don't use this, guys. We use what we call as XL, remember. So that's going to be 0.89 times 31.42. And that equals to 27.96. For this one, it's going to be 0.89 times 21.22 equals 18.88. So after that, that should be it. However, also a very quick thing. So usually, you know, like Kirchhoff's law says that like the voltage coming in is the voltage coming out. Well, over here you can say like, oh, the 20 is here and this is more than 20 already, at least for this one. So how in these situations what you do is like, this is different because like the different components, blah blah blah. The voltage here equals the square root of VR squared, so this one, and then plus the VL, I mean, so like that's this one. Then take away the what was it, VC. Basically it's the same thing where we did it before, but like, oh my god, my brain is not working. Blah! But basically, yeah, that's what it is. Oh my god. Guys, I need motivation for these videos. Motivation. After that, here's the next question. Basically, here we're looking for the frequency, blah blah blah. And by using the formula, like in the formula sheet, there's no equation actually like for the frequency, but there is this one. So look, this is the capacitor, right? So there's an equation, 2 pi frequency C. So we need to make this feed the subject, and that will be F equals 1 over 2 pi XSC. So will it? Yeah. Yeah, it will be. So basically we have to use our formula to understand all of it. I'm just looking at basically at what we have right now in our brain. So basically, first of all, let's just calculate what this is. 2 times 10 to the power minus 6. just thinking, how do I do this? Let's just list what we have. The voltage. We have the voltage is 60. We have the resistance, which is 56. We have the capacitance, which is what is the capacitance? Strange that I haven't listed it. Okay, let's just put it as this. Like, let's not work it out. Let's just put it as this for now. And then we have the current, which is 0.16. And we're asked for the frequency. 32. What is 32? Okay, so look. We're not given XC because XC is different. We worked it. I don't know how to explain it. Basically, we don't have it. So we have to use the formula again. So, and the formula we're going to use is this one. Squared. And so we're going to rearrange it to make XC the subject. Oh no, wait. Okay, so basically, let's get rid of the square root straight away. To make it less confusing. RC plus. And then to make this the subject, we're just going to move it here. No, we're going to move this here. R squared equals. So yeah. After that, we have to work out what is what. So, we know that I equals VC. And we know the V, we know the I. So basically, I move this here, becomes a times C. Move this here. Wait, how do I do this? Okay, basically these two, they switch places. So it becomes Z equals voltage I, 60 divided by 0.16 equals this. So this is Z. So 375 Z, take away R squared, 56 squared, 3136. Oh no, this is wrong, because basically, remember how we did the square, we took away the square root, we did it by times in it, like giving a square, so the R is squared, so 375 squared, take away 57 squared equals. Yeah, that does make sense, if I'm right. So basically, R75 squared equals 146. No, thank you. 205. Take away 56 squared which is 3136 equals, yes, this, and then we square root this number because we, yeah. Right. So basically this equals to xc squared. So how did I get this number? It does seem right. Okay. And after that we have to use this formula. So 1 over 2 times pi times 3 7 3 7 no 37.795 times c, which is c is 32 times 32 to 10 to the power minus 6. Yeah. And all this equals to oh my god. Let me just do my calculator. Times 3. Yep. This equals to 13.41, and that's the rounded number up, and the frequency is measured in hertz. So this is the answer. Thank you very much. Goodbye.